Dear students, welcome to our class on dust and snow storms. Dust and snowstorms, as also sandstorms. Okay, now see, sand or dust storms are caused by very strong winds, often produced by thunderstorms. Now you are seeing in front of the car so much of sand. Yes, to the right side, if you see, a car is also parked, which is due to, in my fairest opinion, because of the sandstorm, that small car is parked there. So, sand or dust storms are caused by very strong winds, often produced by thunderstorms. There is a thunderstorm, then comes the sandstorm. Now, in dry regions, the winds can pull dust from the ground up into the air, creating dust storm. If it is in place of dust, if it is a sandstorm occurs. So these two features allow winds to build up momentum, causing the winds to grow, okay, stronger and drive more sand into the atmosphere. Here you are seeing in front of the yes, now from the window you can see that lot of sand is being lifted by the strong, very strong otherwise winds. Now, what happens during a sandstorm? Generally, what happens? Now, this is what happens here. You are seeing from the front view of the vehicle. You are seeing, sandstorms arise from a gust front. It is formed by a gust front or other strong wind which blows loose sand and dust from a dry surface. These are all the dry surface. Now you are seeing on the road, it is a dry surface. They just, okay, blow the wind. Fine particles are transported by saltation and suspension. You know what is saltation and suspension? It is a process that moves the soil from one place and drops it in the other place. This is the saltation and suspension. Now you are seeing the dust. See, above the what do you call, road, this much of sand and dust is there. 90% of it is sand. Of course, what is the difference between the dust and sandstorm? I told several times that it is down to the size of the particles. That's it. If a question is given, size of the particles. That's it. Nothing more than that. Now, do sandstorms have lightning? Now, it's a very interesting question. Of course, there is a, now you are seeing the sand being lifted from, okay, when you are facing your palm top or laptop, okay, from the right side, sand is driven over the road to the other side. Sand is driven by strong winds from right to left side. This is the right side. Okay, so to the left, the sand is being drifted. Now, see, sandstorms can generate spectacular lightning displays. Spectacular. It's a science is yet to establish what are the reasons. However, they do. They are still a mystery as of today, in my fairest opinion. Several of my books I have tried for answers. Now, you are seeing the snow storm. Snow storm. You see, just half minute back, you have seen the sand being drifted across the road. Here, the snow is drifted. You can ask me how snow will be like a sand. Yes, when in the atmosphere there is a little saturation. Of course, little you can say water vapor. That means dry. So you are seeing the clouds, stratocumulus, nimbostratus, different three types of clouds you are seeing. Now, right side, okay, of the car, the dry snow, small grains like much bigger than, certainly much bigger than uh, sand particles. So the snow particles, snow flakes, in other words, snow particles that is called because it is a dry snow. A dry snow I covered earlier also. If you try to recollect, children play with a dry snow Okay, just like sand, small, okay, um, holes in the snow, they make it, and then they make different structures like. So, this is the snow which is drifted from right side to left side. You are seeing stratus, nimbo stratus clouds, same clouds, but instead of water droplets, you will find snowflakes in the water drops. Through sublimation, they become the no. So now from right side to left side, like sand, here the snow is going. A snowflake begins to form when an extremely cold water droplet freezes onto a dust particle in the sky. That's what I told. A snowflake begins to form when an extremely cold water. Okay, extremely cold water droplet, minutest of the minute droplet, okay, freezes onto a dust particle. It's directly freezes. Water droplet directly freezes. So when atmosphere has less saturation, that means there is no saturation. There is no much water vapor. And those situations, these sand like, of course, much bigger particles than sand like snow crosses. You are seeing in front of the car view. Okay, yeah, this is what. Now, you see a sandstorm like a dust storm. I'm interested to share with you a, uh, a snowstorm. This is a snowstorm. Earlier we saw sandstorm. Almost same day in um, two different continents, okay, South Asia, that we have taken the sandstorm. Here in the Northern America, we have taken this snowstorm. Now you see, a snowflake begins to form in a systematic way. Snowflake, what you are seeing, they are formed in a systematic way. The ice crystals that make up snowflakes are symmetrical. Okay, symmetrical pattern we call it as, because they reflect the internal order of the crystals, water molecules as they arrange themselves in predetermined shapes. Of course, we call it as a crystallization to form a six-sided snowflake. As on today, the science says six-sided snowflakes are identified. Now you are seeing innumerable six-sided snowflakes in the snowstorm. Earlier it was the sandstorm. This is the snowstorm. Now, ultimately, it is the temperature at which the crystal form. That is very important. And to a lesser extent, the humidity of the air, so that determines the basic shape of the whether you call it as ice crystal or snowflake, whatever it may be. Now, very interesting thing I would like to share with you in addition to this is you see, uh, we find some word called as a wind chill. Wind chill. This is based on the rate of heat loss exposed skin caused by wind. Now I am experiencing wind chill here. What is wind chill? As the wind speed increases, it draws heat from my body, driving down my skin temperature and eventually the internal body temperature of me. Therefore, now, actually, outside temperature is -5 or -6 degrees centigrade, but I am feeling due to wind chill plus 5 to 7 degrees centigrade. That means 12 or 13 degrees centigrade. I am feeling while taking this video. So, of course, we usually encounter slightly different atmospheric conditions along the way in the ways like this. Therefore, they all tend to look unique, resembling at prisms, needles, lackey pattern like snowflakes. Also, I would like to share another important point that snow forms when tiny ice crystals in clouds stick together. First, in the clouds, what happens? Water droplets are formed. Water, after taking 540 to 600 calories of energy, goes into the atmosphere, cloud is formed. So that means water molecules are there. Water, tiny drops are there. Now here, snow forms when the tiny ice crystals, water is formed into tiny ice crystals due to sublimation. in the clouds, they stick together and become snowflakes. If enough crystals stick together, they will become heavy enough to fall to the ground. Now we are seeing falling of the snow crystals because many crystals stick together. Now snow is formed when temperatures are low and there is moisture in the atmosphere in the form of tiny ice crystals. Here you see, moisture is very, very important. That's what we call it as relative humidity. The amount of water vapor present in the atmosphere to the amount of water vapor required for saturation, we call it as humidity. Now, similarly, now snow forms when tiny icy crystals in the clouds stick together. That's what I told. If enough crystals stick together, they fall to the ground. Snowflakes that descend through the moisture that is slightly warmer. For example, slightly warmer than 0 degrees centigrade. Okay, they melt around the edges and stick together to produce big flakes. And snow is formed when temperatures are low and there is moisture in the atmosphere in the form of tiny ice crystals. This is what I would like to share. Differences between the sandstorm and a snowstorm. This I was very much interested to show you in reality. Thanking you for your patient hearing.